Hey guys, how's it going? Welcome back to another hack of OpenJDK, and this time we will improve the performance of BufferedInputStream. Maybe you remember an OpenJDK contribution I did last year. If you don't, then you should check this video, which explains what I did last year to improve OpenJDK's performance when it comes to NIO. And I noticed that when you are using a chain of streams, for example, a buffered input stream wrapping a file input stream, then you don't have much benefit from my contribution of last year. Not just because file input stream is, well, a bit of outdated, but also because when you are wrapping a stream by a buffered input stream, then you completely switch off what I did in that video. To better understand what I'm talking about, let's just dive in my latest contribution, and I will show you in the original source code what I'm talking about. So this is my latest contribution. As you can see, it is closed. By the way, closed does not mean it is not merged, which it normally would if you check the majority of projects on GitHub. In OpenJDK, closed also means it might be merged because they're using their own Scala scripts and doing some magic in the background. So actually it is merged. It is part of OpenJDK 20. And what I did actually is rather simple. If you look into the source code of BufferedInputStream, by the way, looking into the original source code of OpenJDK is really a good way to learn how Java is working and to learn how you should use Java or how you should write your own code. It's really interesting to see what they did and why they did it, because often a simple solution is, well, rather complex to do, and so it was with this contribution too. What I did last year was optimization of the NIO streams. So in a nutshell, to offload the task of copying bytes from one stream to the other stream to the operating system. And I noticed that the optimization is not chiming in all code. So what was the problem? The problem is that a lot of existing code that deals with file I/O in particular is using BufferedInputStream as a wrapper to the original streams. So like BufferedInputStream around the NIO input stream or around the file input stream, for example. So why is that preventing my optimization? Simply because BufferedInputStream did not have an implementation of transfer to, so the superclasses implementation, which is input stream transfer to, did simply a loop, and this loop fires GET requests to get data from the wrapped input stream, and the buffered input stream's GET or its read method in Java syntax, it pulls only chunks of data into the memory, and then I'm screwed because I don't want to pull all that information of the wrap stream through that buffer in the buffered input stream. So it was completely in vain to provide my optimization of last year when existing code always uses buffered input stream, which by the way is not that essential anymore since we have NIO anyways. So what can we do to improve that existing code? I don't want to change all existing applications and remove the buffered input stream. That's nonsense, because there are good reasons to have that buffered input stream still, even with NIO. So, well, we need to override the transfer to method in a way that checks if there is something in the buffer, and if yes, we have to drain the buffer, and if no, or after we have drained the buffer, then we can simply call the wrapped input streams transfer to method, which is already optimized, which is what I did last year. So this is what I tried to do in this contribution. So what you find here is the code that finally made it into OpenJDK. It's not the code I started with. I don't dare to show you that code. It was simply too naive. And why was it too naive? Well, for example, because I used synchronize to prevent writing or closing the wrapped input stream while I'm in the transfer loop. And while synchronize is greatly enhanced in the past years, it still is slower than other ways of synchronizing things. So what OpenJDK does internally is not using synchronized, it is using injectable locks. So what you can see here in line 592 is that I have to check if there is such an injected lock, and if yes, I'm calling lock. And if I don't have an injected lock, then I'm in the original Java, pure Java case, then I have to do synchronize this. So to not repeat the code, I had to move it into its own method, and the OpenJDK way to name things is to name it impl and then the name of the method. So this is impl transfer to. This is what I do here and here, depending on whether I have an injected lock or if I have to go with the original synchronized keyword. Here certainly I'm unlocking things if something goes wrong or if not, so we're in the final here. So this is why it looks a bit more complex, but there is more in that. So let me scroll a bit. What we see here is the actual optimization that happens inside of the locking. And the first thing you stumble upon is there is a get class equals buffered input stream class. Oh my gosh, what's that? This is a point you have to care about when writing extendable classes. I'm a big fan of the final keyword. I know you hate it. It really clutters everything, but if your class or your method is final, then nobody can override it, so you have no problems. Buffered input stream is not final, so it is extendable. So there could be cases where somebody has overwritten, for example, the read method of buffered input stream in his custom subclass. And by doing so, we have a problem, because as there wasn't an original transfer to implementation, the input stream transfer to implementation was called in turn, and this in turn called read, and read might be overwritten by your subclass. So I'm leaving out that reads, possibly rendering your subclass completely dysfunctional. And this is something that must never happen in OpenJDK. There's a rule in OpenJDK that existing code must never be rendered dysfunctional by changes in the OpenJDK. So what can we do here? We cannot make this method final now because it would make your code uncompilable. So there's only one trick. We can say we are checking if the executed class is actually the class we have modified here. So this is something I never did before in my life, because I have not written libraries before. And my code always is final, by the way. And if I want to change the code, I remove the final. So this is a safety means you have to do when extending OpenJDK. The next point is, and now it gets interesting, I checked whether the buffer is filled. So this computation simply says, is the buffer filled of the buffered input stream? And if it's filled, then I'm completely skipping my optimization and do the original code, which is simply input stream transfer to. Why am I doing that? Well, simply because it's not that easy to prove that, well, piping all the data from the buffer to the other stream is correct in all ways. So there might be use cases, might be side cases where that is wrong. So the OpenJDK team did a proposal. They said, okay, let's skip the case where you have to deal with the buffer in the first shot. So we merge this code, and after that we start a second pull request which removes this and does what I wanted to do. I wanted to push the buffer in the output stream. So this is an incomplete optimization. It's a complete pull request and it's merged, but it's an incomplete optimization. The solution for this one is currently checked by the OpenJDK team. I contributed it, and I hope that the next video, or one of the next videos, will talk about the solution of this one, which makes the optimization work in much more cases. And here is another case where the optimization cannot work. In the case that you used the mark method, which is good for marking a position in the stream and jumping back to that position to replay the buffer content multiple times. If you use that marking, then you essentially need a buffer. And my optimization, you remember, is to pass by the buffer. So when I'm passing by the buffer, what happens if somebody does a mark before and a reset after that? Well, it's quite obvious that the replay won't work. So I would break existing code again, and I would break the contract of mark and reset. So we decided that we will skip the optimization if there is a mark set. That does not mean that it's impossible to implement a solution that applies the offloading even with a mark being set, but well, we have not found a solution quickly and easily that is really safe in all cases. So if you have an idea how we can write this code that it will call the transfer to method of the input stream even in case a mark is set, and that will work correctly when resetting to that position, then we would be really happy if you could either send us an email or go to Twitter or write a comment under this video, or do a video on your own explaining that trick. But we would be really happy if you tell us what you think could be a working solution in all cases that works with mark and reset in place. So the last line is the actual optimization. So you can see I'm talking since 15 or 20 minutes now. A single line of optimization. This is the single line here. This is the optimization. Needs a lot of work around to work in all cases, to work with all existing code, to not fail in special conditions like being in a subclassed buffer input stream, or being in a marked input stream, or having the buffer filled. So doing libraries correctly is really, really complex. And this is what I meant in the start. Look into the source code of OpenJDK to see how complex it is to write code that behaves correctly and does performance optimizations at the same time. By the way, if you're asking yourself what getinf if open is, this is a method that exists in the OpenJDK implementation of BufferedInputStream. It simply checks whether the wrapped input stream is actually open or was closed before calling transfer to. Why do I need that? Simply because if you look into the Java docs of transfer to, there it says if the wrapped input stream was closed, then I have to throw an IO exception. And instead of writing my own check, I'm using the check method that already exists here. this is something you should always do. If there is a utility method that does what you want, always call the utility method and don't implement it with custom code, because you would do it wrong, possibly. Maybe you would do it slow, but in any case, you blow up the code size that has to be reviewed, and it has to be maintained, and it has to be compiled, and it has to be loaded when your program starts. So this is always better. Also, you help the hotspot compiler to compile earlier when it sees that the same code is called again and again. So as you can see, in a very small contribution, you have one line that actually helps to improve the performance. By the way, it helps a lot because it allows to offload. But you have a lot of things to care about, like the different kinds of locking in OpenJDK, the possibility that somebody has overwritten the read method in a subclass, the possibility that buffered data would go wrong in some way. We will check that. And the possibility that you cannot reset to a position that is not inside the buffer because you skipped the buffer. So it's quite complex. But what gets even more complex is the test. And I will not go into details of the test because it's really simply a copy of what we did in last year's video when we introduced the performance optimization originally. So I simply extended it to some checks. For example, this one. This is more or less one of the sole things, and this one that extends that original test. So watch last year's video to understand the test case completely. Just in short, we extended it to fill actually the buffer and see what happens. And we did the mark and reset game to see what happens if there is actually a mark set and later reset. So the rest is really the same code as last year. So to sum up, how is the optimization working? Simply spoken, we are overwriting transfer to. We take care that nobody is getting harmed. We take care that the wrapped input stream is actually open, and then we are simply skipping the buffer in case the buffer is empty, and if the buffer is not empty, or if we have set a mark, then we use the original code, which leads us to the work in future, which is first one, let us flush all the buffer content to the input stream before, so we can call the optimization in that case too, which is, by the way, I know the majority of all cases, because if the buffer would be empty always, then you wouldn't do a buffered input stream. So this is really essential to make it right, and this is why it's currently checked by the OpenJDK team. I contributed the code, it is working, but we have to take care it's not harming anybody's code. And there's left over that mark reset is working, because I could imagine that it's possible, even if a mark is set, that you check if the original wrapped input stream is able to do mark and reset too. So maybe we could jump back into the buffer if it's buffered, and if it's not buffered data, then we could, well, possibly mark the original stream before to jump back to that position. That should be possible, I think, but I don't want to tell too much. Again, if you know a working solution, propose it to us. So far for today, hope you liked the video. If you did, then please give me a bold thumbs up. Come back to see more videos. Press the button to subscribe and let the bell ring. And as always, stay safe and party on.